So I'm going to include all three sections in this vocab for us here. And the same thing with the read and got it. I'm going to give you a couple days for it. I'm not going to throw it all at once, but it's part of it's so rudimentary and it's not really any different than what we've done with equations. So it kind of makes sense to throw it all together. So inequality, make sure you understand that, a mathematical sentence that compares the value of two expressions using an inequality symbol. So x plus 3 is greater than 4, right? The inequalities we have, by the way, we have less than, greater than, less than or equal, greater than or equal. We can also have not equals, inequality signs. The solution of an inequality is any number that makes an inequality true. For example, if I say that x is less than 3, I can pick, again, as long as it makes sense, like if it's a story problem, any number less than 3 in this case. So I can pick 2.9 repeating, right? I could pick negative 4. I could pick 0. I cannot pick 4, right? I cannot pick 3.0001. Okay? Again, those inequality symbols, greater than, less than, greater than or equal to, less than or equal to, and not equal to. Okay, so graphing your inequalities. This is important. If you have an equal sign, well, we'll start without the equal sign. We'll start with this one. X is greater than 5. Okay, so we've got, here's a 5, here's a 6, here's a 4. If I say x is greater than 5, obviously that's all numbers bigger than 5. But the thing is, there's no equals part. X doesn't equal 5 in this case. So I put I call it an open dot at 5. It's a dot, but it's not filled in, that indicating 5 is not part of the solution set. And it's everything to the right because it's greater than. So 6, 7, 8, 9, right? 5.0003, okay? It's nothing to the left, though. It's not 4.99999, right? Not. So x is greater than 5, gets an open dot at the number 5, and I graph everything to the right. I always draw like this and then an arrow to indicate where I'm going. Should have written a little bit smaller. So if I have a is less than negative 3, so here's my number line. We have negative 3, negative 4, negative 2, and you guessed it, it is open at negative 3. An open dot because negative 3 is not part of the solution, but it's everything that's less than that, so going to the left on the number line. Now I'm going to try to write smaller for this next one. S is greater than or equal to negative 22. So here's my number line. Here I have negative 22, negative 23, negative 21. This time there's an equals portion to the statement. So I fill in the dot at negative 22, and I do all the greater than numbers heading to the right. Okay? Now, continuing, we have m is less than 30. So we draw this, and we say 30 and 31 and 29. Notice I picked numbers around it, right? And it's filled in at 30 because 30 is part of the solution because of the equals thing. And it's everything less than that, so heading to the left. That's it. Let's talk about not equal to here. So graphing not equals to is a little more fun, I think. When I graph, so this one, again, it means everything but 0. So f is not equal to 0. It's every number but 0. So here's 0. Here's negative 1. Here's positive 1. We put that open circle at 0. Everything to the right, everything to the left, just not 0. Moving forward to 3-2, solving inequalities using addition and subtraction. So here we go. For every A, B, and C that are elements of real numbers, in other words, they're real numbers, and you'll know what this elements thing means soon enough. That's in some sections coming up, loads of fun set stuff. So if A is greater than B, you can add C to both sides and it doesn't change. If A is less than B, you can add C to both sides and it doesn't change. Where that comes in handy is if it's something like x minus 3 is less than 4. I can go ahead and add that 3 to both sides, and x is less than 7. That's all it says. Alrighty, so solving inequalities with multiplication and division. Here's where it gets a little bit hairier. The multiplication property of inequality. That says for all a, b, and c that are real numbers, when c is positive, so if I multiply both sides by a positive number or divide both sides by a positive number, nothing changes. So if I have 3x is greater than 4, I go ahead and divide off that 3, and x is greater than 4/3. There we go. But here's where it gets hairy, is if my c, the thing I multiply or divide by, is a negative, that's going to change things a bit. I'm going to show you that in the next slide here. So if I have, so again, let's make sure we understand, if I have x divided by 3 is less than 4, obviously I multiply both sides by 3, just like with equations, x is less than 12. Nothing changes, it works just like equations. But if I change one little thing, say we have negative 3x is greater than or equal to, let's say 12. Obviously, I'm going to divide by negative 3 on both sides to solve. When I do that, I immediately change the inequality symbol. I flip it around. So we get x is less than or equal to negative 4. So the big difference is when I multiply or divide. So when I personally multiply or divide by a negative in my quest to solve, I have to flip the inequality symbol. Let me show you one more. If I have, let's say, 4x is greater than or equal to negative 20. I'm obviously going to divide both sides by 4. Now the thing is, yes, I have a negative here, but I did not personally multiply or divide by a negative in my quest to solve. So here, the inequality symbol does not change. It stays the same.